What if, right now, while you are going about your day, one of the planet's most electrifying, mysterious light shows was flickering directly overhead, and you had no idea? Imagine this. In the dim, early hours before sunrise on the 3rd day of July, an event unfolded far above, hidden from nearly every eye on Earth. As continents slept under a velvet sky, NASA astronaut Nichole Ayers, circling more than 250 miles above the surface in the International Space Station, gazed out into the darkness. Suddenly, a flash, brilliant deep red, rippled through the upper atmosphere. Ayers raised her camera, captured the moment, and later shared it with the world alongside a simple, awestruck message. Just, wow. But what did she witness? And why has this brief phenomenon sent a surge of fascination through the scientific community and beyond? To unravel this, we need to journey high above the clouds, into the rarely explored layers of Earth's atmosphere, and into one of science's most thrilling frontiers, the world of sprites and transient luminous events. Let's turn back the clock. For hundreds of years, tales circulated among sailors, pilots, and rural observers. Accounts of ghostly lights flickering above thunderstorms. Stories so rare and strange they bordered on myth. These lights were said to flicker just for an instant, far above the main body of the storm. In the centuries before modern technology, few believed such stories. They were dismissed as hallucinations or tricks of the eye. Another case of nature spinning tales through the minds of weary travelers. Yet the truth, as it often does, proved far more incredible. In the late 1980s, specifically, the year 1989, a team of scientists in the American Midwest changed the course of atmospheric science forever. On a stormy night, they captured the first photographic evidence of what would later be called sprites. For the first time, blurry folklore became scientific fact. The discovery opened a new chapter in our understanding of the upper atmosphere. Sprites belong to the larger family of transient luminous events, or TLEs. The name may sound technical, but the phenomena are pure magic. Sprites are massive, fleeting discharges of electrical energy, manifesting as radiant red flashes far above thunderclouds, at altitudes ranging from 50 to more than 90 kilometers above the surface. Picture giant tendrils of crimson light, sometimes shaped like jellyfish, carrots, or trees, blooming in the thin air of the mesosphere. These displays last less than a single millisecond, so brief that, unless you are looking at the perfect moment, you might never know they were there. What triggers these elusive light shows? Sprites are born from the intense electrical drama inside powerful thunderstorms. Most often when a rare form of lightning called positive lightning leaps from the top of a cloud to the ground. Unlike the more common negative lightning, positive lightning carries far more energy. When such a bolt strikes, it can set off a chain reaction in the thin upper air, causing a cold plasma discharge, what we see as a sprite. NASA explains that these events are so powerful, they not only create light, but also trigger chemical reactions, shifting the delicate balance of gases in the upper atmosphere. For years, sprites were seen as little more than oddities, beautiful but unimportant flashes in the sky. But as technology advanced, so did our understanding. High-speed cameras, some capturing tens of thousands of frames every second, began to reveal sprites as intricate, layered structures. Instead of simple flashes, they appeared as branching, complex patterns, sometimes with glowing roots reaching downward and filaments stretching up toward space. Some sprites look like vast, diffuse domes. Others, nicknamed carrot sprites, feature a thick central trunk and a crown of branches. Still others, called jellyfish sprites, spread wide like the tentacles of a cosmic sea creature. Each sprite is unique, shaped by the storm that births it and the complex currents of the upper air. Sprites rarely appear alone. They are often accompanied by other TLEs, blue jets, which shoot upward from the tops of thunderclouds, and elves, which spread out in huge, fast-expanding circles. Imagine, for a moment, a single thunderstorm triggering a light show stretching from the cloud tops nearly to the edge of space, a multi-layered, silent fireworks display, invisible to almost everyone below. These phenomena are not just visual wonders. Dr. Lee Marshall of Penn State University puts it this way: the electrical parameters of the atmosphere can have a strong effect on the chemistry of the upper atmosphere. Sprites, in other words, are not just flashes of light. They are messengers, transferring energy and information between different layers of the sky. Every sprite briefly alters the mixture of gases, especially nitrogen and ozone, in a region crucial for shielding Earth from cosmic radiation. As the 21st century dawned, The study of sprites leapt from the margins of academia to the heart of meteorological research. Thanks to fleets of satellites, ground-based observatories, and a new generation of enthusiastic citizen scientists, we now know that sprites are not as rare as once believed. In fact, they occur hundreds, sometimes even thousands, of times each year, on every continent and over every ocean. Scientists have documented sprites above the plains of North America, the savannas of Africa, the mountains of Asia, and even the open Pacific, wherever powerful storms rage. A landmark moment arrived in the year 2022, when NASA launched the Spectacular project. This citizen science initiative invited people everywhere to point their cameras skyward and join the hunt for sprites. The response was overwhelming. More than 800 volunteers from over 20 countries joined the effort. And together, they confirmed more than 360 sprite sightings. The Spectacular community now stretches from North America to Europe, Africa to Australia, building a global network of observers and data collectors. Berku Kosar, one of the project's leaders at NASA, says, "Spectacular bridges the gap between the public and the science community. Every photo, every video, every sighting adds a piece to the puzzle, helping scientists build a more complete picture of how, where, and why sprites occur." The collaboration has not only expanded our catalog, but also revealed new patterns, such as how sprite frequency changes with the seasons, or how certain regions seem especially prone to these phenomena. But sprites are more than just beautiful curiosities. Recent research has shown that they can alter the chemical makeup of the upper atmosphere, particularly the balance of nitrogen oxides and ozone. These changes, though fleeting, can affect how our planet retains or releases heat. Some experts now believe that spikes in sprite activity might serve as early warning signs of larger shifts in Earth's electrical climate, a kind of heartbeat that pulses with every major thunderstorm. If we can learn to read these signals, we might be able to predict shifts in weather patterns, or even in the broader climate system. Space-based observations have revolutionized sprite research. From the vantage point of the International Space Station, astronauts like Nichole Ayers enjoy a clarity and perspective impossible from the ground. They look down on storms from above, free from the interference of clouds, haze, or city lights. The photos and data they gather are now helping scientists refine weather models, sometimes allowing meteorologists to spot early hints of storm intensification even before traditional radar picks up danger signs. Imagine the possibilities. Earlier warnings for hurricanes, tornadoes, and megastorms, more time for communities to prepare and respond, lives and property saved. But the impact of sprite research goes even further. Sprites deliver vast quantities of energy into the mesosphere, a region vital for the transmission of radio, television, and satellite signals. During intense storms, the disruptions caused by these discharges can interfere with everything from commercial aviation to financial transactions routed through satellites. In an age when a single lost signal can ground planes, disrupt supply chains, or even threaten lives, understanding sprites is no longer a luxury. It is a necessity for modern society. Dr. Hailiang Huang from the University of Science and Technology of China underscores the importance. Understanding TLEs helps us learn more about the storms we face here on Earth. Sprites, in other words, are woven into the fabric of our weather, our technology, and our daily lives. As our understanding grows, so do the questions. Why do sprites sometimes appear in clear skies, far from any obvious thunderstorm? What hidden forces in Earth's global electrical circuit, an invisible web of energy stretching around the planet, are at play? Some scientists suspect that changes in the planet's climate are subtly shifting the frequency and intensity of sprites and other TLEs. Recent studies have found intriguing hints that increases in sprite activity may be linked to small but measurable changes in global temperatures. Could sprites act as indicators of deeper shifts in the planet's atmospheric chemistry? Or could they even play a role in how Earth stores and radiates heat? These are questions at the cutting edge of climate science. Sprites also reveal something universal about electrical phenomena. Similar events have been observed on other planets. Gigantic lightning discharges on Jupiter, peculiar flashes on Venus, and ghostly glows on Saturn. By studying sprites here on Earth, scientists hope to unlock the secrets of distant worlds, learning about their weather, chemistry, and perhaps even their potential to host life. Technology is fueling this new era of discovery. Satellites equipped with ultra-sensitive cameras and spectrometers can now capture sprites in wavelengths beyond the reach of the human eye. Ground-based networks, using arrays of synchronized high-speed cameras, can triangulate the exact location, shape, and duration of every sprite, building three-dimensional models of these fleeting events. Even amateur astronomers, armed with nothing more than digital cameras and determination, have contributed breathtaking images that have advanced our understanding. The Spectacular project is proof of what collective curiosity can achieve. As Joseph Bohr of Hungary's Institute of Earth Physics and Space Science puts it, the power of the community makes Spectacular very strong for TLE-related scientific work. With every new sighting, every shared photo, the boundaries of knowledge are pushed back. So, how can you join this electrifying quest? Start with a camera, a DSLR, a mirrorless camera, or even a modern smartphone with manual exposure controls. Find a place far from city lights, with a wide, unobstructed view of the horizon. The best time to hunt for sprites is during or just after a major thunderstorm, particularly in summer when atmospheric conditions are most favorable. Patience is essential. Sprites are unpredictable, and hours may pass without a single flash. But when one does appear, the thrill is unforgettable. If you capture a sprite, share your photo with NASA's Spectacular project or with local research groups. Each contribution helps build a global database, turning every observer into a vital link in the scientific chain. Imagine the excitement of knowing your image helped decode the mysterious workings of our planet's atmosphere. The reach of Sprite research now extends into industries you might never have expected. Airlines are starting to use TLE data in flight planning, rerouting planes to avoid areas where upper atmosphere electrical activity could threaten avionics or passenger safety. Shipping companies, dependent on precise satellite navigation, monitor Sprite forecasts to anticipate communication glitches. Energy providers are exploring whether bursts in Sprite activity could signal impending shifts in weather, allowing them to better manage power grids during storms. Across the sciences, sprites have become a source of fascination and inspiration. Atmospheric chemists are investigating whether sprites create exotic molecules in the mesosphere, compounds that could influence everything from ozone formation to the breakdown of greenhouse gases. Electrical engineers are building models to simulate how energy travels from the ground to the edge of space, hoping to better predict and mitigate the impacts of extreme weather. Some even speculate that, by studying sprites, we might uncover clues about how lightning and plasma help spark the chemical reactions that led to life itself. Despite these advances, vast mysteries endure. For every sprite captured on film, dozens more flickers unseen, their energy dissipating into the night. Why do sprites cluster in some storms but not others? How do they interact with gravity waves, auroras, or other atmospheric phenomena? What role might they play in the evolution of Earth's climate over centuries or millennia? As research accelerates, sprites are emerging as a keystone in the study of extreme weather and atmospheric science. The ultimate vision is a world where meteorologists, engineers, and citizens work together, using data from sprites and TLEs to build safer cities, smarter infrastructure, and more resilient societies. Every new discovery brings us closer to a future where early warnings for natural disasters are routine, not rare. And here's a compelling twist. Sprites are not limited to chaotic storms. They have been recorded in clear skies, in the lull before the next front arrives, and even above the calm eye of hurricanes like Matthew as it swept through the Caribbean. This unexpected diversity suggests that sprites are part of a far bigger story. A story connecting the dance of lightning and plasma to the rhythms of our climate, our technology, and perhaps even the origins of life on Earth. So what does all this mean for you? It means that the wonders of science are not out of reach. With curiosity, a camera, and a willingness to look up, you can join a global community rewriting the story of our skies. Your contribution, whether a photograph, a question, or a moment of awe, could help forecast the next megastorm, safeguard a critical communications network, or inspire the next generation of explorers. If you have ever wanted to be part of something bigger than yourself, now is your chance. The sky is vast, the mysteries are many, and the next, just wow, moment could be yours. Keep your eyes on the night sky. Join the worldwide family of sprite hunters, and help illuminate the secrets swirling above us all. Subscribe to our channel for more astonishing stories at the frontier of science and technology. And if you spot a sprite, or have your own questions about this mesmerizing phenomenon, share your thoughts and photos in the comments below. You may be closer to a breakthrough than you